Okay, so let's go ahead and look at page 11 in our notes. So this page should be in your packet. And it's talking about some analytic methods that we could use to find a limit. So we already said we could look at a graph. And we said that we could look at a table. And as long as we knew those, we could add, subtract, you name it. Now, what if we don't want to make a graph or a table? How could we find those limits? Well, there's going to be a bunch of things that we can try. Main thing that we're going to look at today, direct substitution. Doesn't always work, but when it works, it's really nice. Okay, so that's all we're going to talk about. So here, I've got a polygon here. Actually, I've got a parabola. And so I'm just going to plug that 2 right in. Now, don't forget your order of operations. You've got to square this before you can multiply. So 2 squared is 4. 4 times 3 is 12. So 12 minus 10 plus 4, that's 2 plus 4 is 6. Okay, so just like if we were making a t-chart. As x approaches 2, well, let's find the y value. Let's just plug it in. 2 cubed plus 1 over 2 plus 1, 9 over 3, it's 3. Uh-oh, natural log, x approaches e, so don't forget when we do our natural log, the natural log of e. That's the same thing as log base e of e. Remember we said last week, if these are the same, that and that, it's equal to 1. Because they're inverses of each other. So the natural log of e is 1. So let's do natural log of e over 3e. That's it. Okay. Over here, square or cube root, no big deal. 4 plus 4 is 16. And then we say, is there a perfect cube inside of 16? Why, yes, there is. There's an 8. So this is 8 times 2. We know the cube root of 8 is 2, but we don't know the cube root of 2. Okay. Oh, good. We get a little trigonometry in here, right? Okay, so let's just plug that right on in. So the sine of 2 times pi over 6. Well, that's just going to cancel. So we want the sine of pi over 3. So when I'm doing this, I'm thinking, okay, pi over 3 is in quadrant 1. That would be a 30-degree angle. And if this is 1 and the sine is the piece across from it, it's the square root of 3 over 2. Okay. And last but not least, a little logarithm. So let's look. We're going to go log base 3 of 5 plus 4. That's log base 3 of 9. Okay, it's been a while. We haven't done these in a while. What I want you to think about is that this equals something. And there's more than one way to look at this, okay? So kind of bear with me here. What this really means is 3 to some power equals 9. And that would be 3 squared. So that is our answer. Ta-da!